This is example 6.6. The problem reads, calculate the number of moles of gas in a 3.24 liter basketball inflated to a total pressure of 24.3 psi at 25 degrees C. Note, the total pressure is not the same as the pressure read on a pressure gauge, such as the type used for checking a car or bicycle tire. That pressure is called the gauge pressure, and it's the difference between the total pressure and atmospheric pressure. So in this case, if the atmospheric pressure is 14.7 psi, which we could assume at 1 atmosphere, the gauge pressure would be 9.6. But for these calculations, you have to use the total pressure. So what they're saying here is, if you are reading the pressure on a gauge for a tire, you've got to add atmospheric pressure to it. And the atmospheric pressure is 14.7. So if your tire pressure is, let's say 10, then your total pressure would be 24.7. So you've got to remember that you've got to add atmospheric pressure to the gauge pressure if you're doing these problems in real life. But for our example here, we were given the total pressure, which is 24.3 psi. So the difference between this problem and the previous problem is that we need to convert everything into the units of R. And remember, R is equal to 0.08206 liters times atmospheres divided by moles times Kelvin. Okay, so we need to make sure our units match up. We need our volume in liters, our pressure in atmospheres, and we need moles for our amount of gas, which is usually in moles, but we might be given grams. We might have to convert grams to moles using the atomic mass or molecular weight. And then our temperature has to be in Kelvin. Okay, so let's go ahead and get started. We know that PV equals nRT, and we were asked to calculate the number of moles. So we're asked to find N. So in the first step, we're going to solve PV equals nRT for N. And so let's go ahead and do that. PV equals nRT. How do we solve for N? We divide both sides by RT, right? So if we divide both sides by RT, RT cancels, and we've got N on a side by itself. So that gives us N equals to PV over RT. Okay, and now we have to do all of our conversions. We have to make sure all of our units are correct. So our pressure, we started with 24.3 psi. We know that 14.7 psi is 1 atmosphere. So we divide by 14.7. psi cancels, and we're left with atmospheres, okay? And so temperature, we need to convert to Kelvin, so we add 273. So you could add 273 or 273.15. It really just depends on how many significant figures you started with. In this case, they just used 273 because that's adequate for our calculations. And N then will be given by 1.6531 atmospheres. That's our pressure. 3.24 liters, that's our volume, divided by R times the temperature. So we got 0.219 moles. Okay, so that's the number of moles. All right, we have 2 for-practice problems. We have a for-practice and a for-more practice problem. We'll go ahead and work those. All right, in the first one, for-practice 6.6, what volume does 0.556 moles of gas occupy at a pressure of 715 millimeters of mercury and a temperature of 58 degrees C? So remember, PV equals nRT, and in this case, we're looking for volume. So volume is equal to nRT over P. And remember, R is equal to 0.08206 liters times atmospheres per mole times Kelvin. And so we have moles here, that's fine, but we need to convert our millimeters of mercury to atmospheres, and we need to convert degrees C to Kelvin so that we can calculate everything else, okay? So let's go ahead and do that. Our pressure in atmospheres is equal to 715 millimeters of mercury, and 1 atmosphere is 760 millimeters of mercury, and that gives us 0.940789 atmospheres. Okay, and temperature in Kelvin is equal to 58 plus 273.15 is equal to 331.15 Kelvin. Okay, and so we can plug everything in now. V is equal to nRT over P is equal to 0.556 moles times 0.08206 liters atmospheres per mole Kelvin times 331.15 Kelvin divided by 0.940789 atmospheres, and that's equal to 16.1 liters. So that's approximately equal to 16 liters. So that's supposed to be, that looks kind of like a K there. Let me correct that. So that's supposed to be 16.1 liters. Okay. All right. I have one more of these problems in this section. Determine the pressure in millimeters of mercury of a 0.133 gram sample of helium gas in a 648 milliliter container at 32 degrees C. So we just need to make sure everything is in our units. Remember, R is equal to 0.0820. R is equal to 0.08206 liters, atmospheres per mole Kelvin, right? So we need our volume in liters. So we need to convert that to liters. We need our temperature in Kelvin. But here's a interesting number. How do we convert grams? We need moles. Our amount of gas has to be in moles. So we have to convert grams to moles, and this is helium. And so we need the what? We need the atomic mass of helium, and that is 4.003 grams per mole. Okay, so let's go ahead and get started. 648 milliliters. And where did I get this number? I got it from the periodic table. 648 milliliters, and if we just divide by 1,000, we'll get liters. So divided by 1,000 is 0.648 liters. And the temperature in Kelvin is equal to 32 plus 273 is equal to 305 Kelvin. And now we need to convert grams to moles. 0.133 grams of helium, and our amount has to be in moles. So 1 mole of helium is 4.003 grams of helium, and that's equal to 0.033225 moles of helium. Now we can get started. The pressure is equal to nRT over V is equal to 0.033225 moles times 0.08206 liters atmospheres per mole Kelvin times 305 Kelvin divided by 0.648 liters is equal to 1.28328 atmospheres, which is equal to 1.28 atmospheres if we're considering significant figures. And now we need to convert atmospheres to millimeters of mercury because we were asked to convert that to millimeters of mercury. So let's go ahead. I'm going to change colors and do that up here. So 1.28328 atmospheres and 760 millimeters of mercury is 1 atmosphere, and that's equal to 9.8 times 10 to the second millimeters of mercury if I'm considering significant figures, because my answer was 975 millimeters of mercury, but I needed 2 sig figs, and I needed it to be unambiguous. So I converted it to scientific notation to make that happen.